Welcome back, mathematicians. In this video, we are going to solve an oblique triangle, and we're looking at the case where we are given two angles and a side. This would be angle, side, angle, or side, angle, angle. Now first, an oblique triangle is a triangle that is not a right triangle. So we're talking an obtuse triangle or an acute triangle. Secondly, to solve a triangle means to find the lengths of its sides and the measure of its angles. So in this instance, we're looking at, or in this case, we're looking at finding the unknown angle and two unknown sides. We've got a diagram to illustrate the two different situations for case number one, where again we're given a side and two angles. To solve this triangle, to find the two unknown sides and the unknown angle, we need to use the law of sines. For a triangle with sides A, B, and C, and opposite angles A, B, and C respectively, the law of sines says sine of angle A over side A is equal to sine of angle B over side B, which is equal to sine of angle C over side C. So what you'll do is set up a proportion and solve for an unknown. Let's now use the law of sines in order to solve this triangle. We are given angle A, which is 45 degrees, angle B, which is 55 degrees, and side A, which is 5 units. Let's start by drawing ourselves a diagram to show what we have and what we need to find. Now this diagram is not drawn with accuracy. It's just to illustrate that information, what we need, and that information, what we have. So let's call the bottom left-hand vertex of this triangle angle A, which is 45 degrees. That means side A needs to be opposite that angle, which is 5 units. Let's call the bottom right-hand vertex angle B, which is 55 degrees. That means the side opposite it would be side B, and that is unknown. The third and unknown angle is angle C, and the side opposite angle C would be side C. Let's start by finding the unknown angle. We know the sum of the interior angles of a triangle is 180 degrees. So that means angle C is equal to 180 degrees minus 45 degrees minus 55 degrees, which means angle C is a value of 80 degrees. We can now find side B or side C, and it really doesn't matter which one we choose to find first. I'm going to go ahead and find side C. That means I'm going to use the law of sines, which states that the sine of angle C, which is 80 degrees, over side C is equal to the sine of angle A, 45 degrees, over side A, which is 5 units. I can't use side B or angle B at this time because I need 3 pieces of known information and 1 unknown. Next, I'm going to go ahead and cross multiply to solve this proportion for side C. This gives me C times the sine of 45 degrees is equal to 5 times the sine of 80 degrees. I now divide both sides by the sine of 45 degrees. This will give me C is equal to 5 times the sine of 80 degrees over the sine of 45 degrees. I should now use my calculator and make sure my calculator is in degree mode, not radians, and what I end up getting is C is approximately 6.96 units. Finally, I need to find the value of side B. To do this, I'm going to repeat the process using the law of sines. So sine of angle B, which is 55 degrees, over side B, which is unknown, is equal to, and now I need to use angle A and side A. I choose that over angle C and side C because 6.96 units was an approximate value, whereas angle A and side A are exact. So this will be equal to the sine of 45 degrees over 5. Once again, I'm going to cross multiply to solve this proportion. So what I get is B times the sine of 45 degrees is equal to 5 times the sine of 55 degrees. Divide both sides by the sine of 45 degrees. So I get B is equal to 5 times the sine of 55 degrees over the sine of 45 degrees. Use your calculator again, and what you get is an approximate value of 5.79 units. So what you have now done is successfully found the 2 missing or unknown sides and the 1 unknown angle and solved this triangle. All right, guys, good luck.